Hi there. We're going to look at 14.1, which is voting methods. So a lot of people know about voting because it's a very, very important thing that we all gain the privilege to do. And in this section, we're going to look at different voting methods. However, I do want to let you know that we are not looking at the Electoral College method yet. So we're going to look at methods that people use to vote, mostly in corporations, not in terms of the whole entire country. So let's go ahead and look at the different methods that we're going to see in 14.1. The first one is polarity. The second one is the Borda count method. The third one is polarity with elimination method. And finally, pairwise comparison method. So the first objective is we have to look at what a preference table is, because if we don't know what this is or how it works, then the other methods aren't going to work well. So the first example that we're going to look at showing a preference table states the planning committee for the San Francisco Zoo is voting on an animal for the new zoo logo. The choices are tiger, which is represented as a T, a kangaroo, which is represented as a K, and giraffe, which is represented as a G. There are 15 planning committee members labeled CM1, CM2, CM3, and so on until we get to committee member number 15. Their ballots are shown in figure 14.1. So here's their ballots. For instance, we're looking at CM1. So I'm going to highlight the one that I'm looking at so you guys know what I'm doing. And if we look at this, we notice that their first choice is T, second choice is K, and their third choice is G. So their first choice would be tiger, second choice kangaroo, third choice giraffe. Let's look at committee member number 13. So committee member number 13, their first place choice would be giraffe, second place choice is tiger, and third place choice would be kangaroo. The CM, just to remind you, stands for committee member. Okay, so the result of the votes can be found below. So if we take each person's ballot and organize them in terms of how they voted, we would see that two people selected in this order: first place tiger, second place kangaroo, third place giraffe. And I'm going to highlight what I just said. And then there were three people that voted in this order: tiger, giraffe, kangaroo. There were 5 people that voted in this order: giraffe, tiger, kangaroo. 1 person voted in this order: kangaroo, giraffe, tiger. 3 people voted kangaroo, tiger, giraffe. And finally, 1 person voted giraffe, kangaroo, tiger. So that's what a preference table looks like. So let's just review this really quick. And each column tells the number of votes each preference got. So once again, in the first column, which I'll put a little check mark above it, we see that 2 people voted in this order: tiger, kangaroo, giraffe. All right, so if you look at the preference table and you add up the number of votes, so I'm looking at what I just boxed. If I add this up, I get 2 plus 3 plus 5 plus 1 plus 3 plus 1, and that equals the total number of votes, which is 15, which makes sense because if you read the example, it said that 15 planning committee members were voting. So the number of votes should equal how many people are voting. Okay, so let's go ahead and check out this next page here. So let's look at the results of a difference preference table just to get used to it. In this example, it says 4 students are running for president of the Honor Society: Antone A, Betty B, Camille C, and Don D. The club members were asked to rank all candidates. The resulting preference table for this election is given in table 14.3. All right, so in the first column, we see that 90 people in the club voted B, A, C, D. 15 people voted C, A, D, B. 11 people voted D, C, A, B. And 7 people voted A, D, C, B. Finally, the last 2 people voted C, D, A, B. Remember the B, A, C, D, like if I'm looking at the first column, that means 19 people voted for B, which is Betty, as their first place choice. Second place choice would be Anton. Third place choice would be Camille. And finally, their fourth choice would be Dawn. So that's what that means. So part A says, how many students voted in this election? So we have to look at the number of votes. So I'm going to add up 19 plus 15 plus 11 plus 7 and then plus 2. So if I add that up, I'm going to get 54. So the total amount of people voting are 54. How many students select the candidate in this order? C, A, D, B. All right, so I'm looking for C first, A second, D third, and B last. And if I look at that, I can see that 15 people voted in this manner. So the answer to that is going to be 15. Part C, how many students selected C as their first choice? Now I'm going to look at, and I'm going to erase this last bit. Just hold on one sec. Okay, so if I take the eraser, I'm going to erase what we had in the preference table. And it says how many students selected C as their first choice? Well, I look at the first row. So I'm right here, first row. Okay, I have a C there, and I have a C here. So 15 people voted for C as their first choice, and an additional 2 did. So that totals out to 17. And that is the answer for this example. All right, so next objective we're going to look at is the polarity method. So this is the first voting method that we're going to look at. And the procedure for it is each voter votes for one candidate. The candidate receiving the most votes is declared the winner. Okay, this is the most popular and easiest voting method to use when we have more than one candidate or item that is being voted on. So most of the time, if you're in a club or if you're in an organization and you're running elections, you're just going to say whoever gets the most votes wins. So do we need a preference table for this? Really, the true answer is not really. However, it's nice to have. And the reason why we don't need one is, once again, remember, whoever gets the first place votes wins. So usually the candidate or item has to have the majority of votes in addition to being, having the most votes to win. However, there are some exceptions to this rule. So let's revisit our first example involving the San Francisco Zoo logo decision. And we have the same preference table we had before. So remember, we're looking at the first place votes only. So what I'm going to do is look through the first place votes because I want to know who won. So I'm going to highlight that, and then we're going to figure out who got the most votes. So if we look at Tiger got 2 plus 3, that equals 5. And then I'm looking at Giraffe. Giraffe has 5, and then 1 more. So that equals 6. And then last is Kangaroo. Kangaroo has 1, and then 3 additional votes, which makes 4. So if I do that, Tiger receives a total of 5 votes, Giraffe receives a total of 6 votes, and Kangaroo receives a total of 4 votes. So using this method, we can see that Giraffe is the winner using the polarity method. However, if we look at Giraffe and figure out the percentage of votes that went to the winner, we're going to find out that it's actually less than 50%. Remember in this case that we have a total number of votes of 15 committee members. And remember that 6 of those committee members voted for Giraffe. So if I take and divide 6 by 15, we're going to find out that we get 0.4. If I change that decimal to percent by moving the decimal places 2 places to the right, I'm going to see that Giraffe has 40% of the votes. So, by the way, that is not the majority. To get the majority, you need 50% or higher. So here's an instant where the majority actually won the vote using the polarity method, but did not have the majority number of votes. And that can happen. So objective 2, this is another method that you can use to vote. It's called the Borda count method. And the Borda count method was created by Jean-Charles de Borda. The method requires voters to rank their choices from favorable to least favorable. The Borda count method then quantifies this ranking method to determine a winner. Okay, so we need a preference table for this one, definitely. What the voters do is rank their candidates from most favorable to least favorable. Then each last place vote is awarded 1 point. Each next to last place vote is awarded 2 points. Each third from last place vote is awarded 3 points, and so forth. The candidate receiving the most points is the winner of the election. So let's see how this all plays out. So we're going to look at the San Francisco Zoo election for the new logo as discussed in the first example we saw. The preference table is right below, and we're going to look at this again. Remember, T is tiger, K is kangaroo, G is giraffe. All right, so Borda count method, I'm going to look at tiger first. So I'm going to put a little T here. And I'm going to look at how many first place votes they have. So I'm going to write out first, second, and third, just to keep track. Okay, the number of first place votes that Tiger had, and I'm going to make a little chart here. The number of first place votes is 5. 2 plus 3 is 5. So first place votes for Tiger is 5. The number of second place votes, and I'm looking in this row here, Tiger got 5 and 3. So 5 and 3 is 8. So they got 8 second place votes. Now I'm looking in the third place row. I'm looking for T's. So there's 1 T and 1 more T. So 2. 2 third place votes. Now with the Borda count method, since I only have 3 choices, third place will be awarded 1 point. Second place gets 2 points, and third place gets 3 points. Okay? If we had 4 selections, then first place would get 4 points, and so on and so forth. Okay, so since I had 5 first place winner, I take 5 times 3, which equals 15. For the second place, I had 8 votes, so 8 times 2, because the second place equals 16. And third place gets awarded 1 point, so 2 times 1 is 2. So if we go down to our chart, and once again, remember, first place voters receives 3 points, second place receives 2, and third place 1. All I have to do now is add those up. So if I add up 15 plus 16 plus 2, so let's look at Tiger, 15 plus 16 plus 2, and I add that up, I get 33 total. Okay, so let's go on to the giraffe. So giraffe, once again, I'm going to write out first, second, and third. Okay, so we're going to make a chart. This is just a little bit easier to understand. And then I need a totals column. Okay, so let's look at giraffe. Once again, we're going to go through the whole table again. So in the first row here, I'm looking for giraffe, so I have 5 and 1, that's 6. Then I'm going to look down at the second place votes. Now remember, I'm looking for G's. So I have 3 G's plus 1 G is 4 G. And then I'm looking in the third row. I'm looking for G's. So I have 2 plus 3, that's 5. Whoops, I used the wrong tool. 5. All right, so now I have to award points depending on what place they're in. So it's 6 times 3, which is 18. 4 times 2, which is 8. And 5 times 1, which is 5. So for kangaroo, we get 18 plus 8 plus 6, which gives me a grand total of 32. Okay. And I put that in the wrong place, so let me fix that really quick. 18 plus 8 plus 6 equals 32. And let me erase that out. Sorry about that, guys. And let me do that. All right, so the last one that we have to look at is kangaroo. So once again, we have first place, second place, and third place. Okay, running out of room here. Okay. All right. So let's check out first place votes. K's, 1 and 3 is 4. Second place, 2 plus 1 is 3. Third place, 3 plus 5 is 8. Now I have to multiply. 4 times 3 equals 12. 3 times 2 equals 6. And 8 times 1 equals 8. So I got 12 plus 6 plus 8. And when I add that all up, I get 26. Okay, so who won? Well, if we look at this, the tiger wins with a Borda count method because it has the most amount of points. So when you compare the two methods that we did, which animal won during the polarity methods? And that giraffe, the answer would be giraffe. And then which animal won using the Borda count method? The answer is tiger. So as you can see, depending on what method you use, you could get different results. Does the voting method matter? Yes. And did you think the voting method should be revealed to candidates before the election? That answer should be yes as well, to be fair. Okay. So objective 3 goes over the polarity with elimination method. And this one's actually very much like the polarity method, but this may require more than one election. So if the candidate wins the majority of votes on the first run, then that candidate wins, no problems. But if none of the candidates have the majority of votes, then the candidate with the least number of votes is eliminated from the second round of the election. The election is held again, and the process is continued until one candidate wins the majority of votes. So once again, this is the next method, polarity with elimination. Each voter votes for one candidate. If a candidate receives a majority of votes, that candidate is declared the winner. If no candidate receives a majority, then you have to eliminate the candidate with the fewest votes and then hold another election. You're going to repeat this process until the candidate receives a majority. So if we look at the zoo example again, here's a preference table. If we look through it, remember that giraffe won with 6 votes, because remember we're just looking at first place. Okay. However, when we do 6 divided by 15, we saw that came out to be 0.4, which is 40% of the vote. So that doesn't work. So we got to find out who had the least amount of votes. Tiger had 5, giraffe 6, and kangaroo 4. So the kangaroo had the least amount of votes. So what we're going to do is we're going to remove kangaroo from the second round of votes. So let's make an assumption that kangaroo, everybody would vote the same. So I'm going to take out and move all the K's out of there. Okay, so what happens is, once again, I'm looking at the second election, and I'm looking at the first place votes. So I still have 2 for T, 3 for T, 5 for G. Now if you look at these 2 columns that I just kind of highlighted here, we're going to move whatever their second choice was up to first choice. So now their first choice is 1G, and then 3T, and then 1G. Do you see what I did? Because my first place got knocked out. 1 person voted for kangaroo and 3 people voted for kangaroo. So that 1 vote went to giraffe, and those 3 votes go to tiger. All right. So now that we have kangaroo eliminated, let's check to see what we have. Tiger, we have 2 plus 3 plus 3. That's 8 total. Giraffe equals 5 plus 1 plus 1. That equals 7. So the new winner is now tiger. So the next thing you have to check, though, do they have the majority of the vote? Okay. So remember, we're looking at tiger. And just to quickly check, they had 8 of the 15 votes. So we have to divide 8 by 15. And when I do that, I get 0.53, changing that to percentage. 50% of the vote goes to Tiger. So that's okay because remember, to have the majority, you have to have over 50% of the votes. So Tiger wins, and that is the answer to this problem. Once again, with a polarity with elimination, you have to check the winner to make sure that they have the majority of the vote. Once again, how do you do that? Take the number of votes divided by the total number of votes. So the number of votes the candidate got divided by the total number of votes and change the decimal to percentage.